Wow, what's happened here? Someone's come by and dropped their box of numbers on my nice white screen. What a mess. What were they doing with a box of numbers anyway? Don't know, mate. And was it this guy? Is he the culprit? Oh, that's a mess, that screen. We need to unpack that later on. But for the moment, I'd like you to pause the presentation and see if you can find the culprit here. This looks like a Roman or Greek mathematician. So I want you to go and search. Can you find perhaps a Greek mathematician who was working fundamentally with number, but he was a philosopher as well? Let's see if you can find out who he is. So pause the presentation and go and search that on the internet and see what you think. Okay, so here we are, back again. Were you good with your searching there? And I wonder if you realise this is a picture of a Greek mathematician and philosopher, Pythagoras. And he had a lot to say about the world and about number and a lot of other things. And one thing that he's reported or reputed to have said is the world is number. He saw a lot of patterns in the world, way the world was structured that were related back to maths. So that's our starting point. Let's look at Pythagoras as saying the world is number. And what numbers can we find? What numbers do we use? What numbers do we define in mathematics? Because numbers are the tools of mathematics. So I want you to look around the screen here and look at this box of numbers, if you like. And I think there are others apart from these, but just this is our starting point. And we're going to get up close and familiar with number, because they are our tools in these coming presentations. This is just part one. And you're going to learn a lot about number. You might know something already, but let's go on now and have a look. So I've got some questions for you, looking around the screen there. And here they are. Here are the questions I want you to try to answer. And you could ask them yourself or divide up into groups and see what you think. Questions for you to answer. How many colours are there? You might have to rewind the presentation, go back. I'll do that in a minute. List each colour and write down the numbers which are that colour. Actually list the numbers. And then looking at them, try to describe what they all have in common. And then do you know any names for numbers that have that in common, that are similar to each other like that? And then, is there a key number which is missing? Okay, so you might pause the presentation and record those questions either on paper or electronically. And then what we've got to do is rewind the presentation so you come back up and you go through this screen. Okay, well now that I've rewound it, you can actually pause it there and have a go. Alright, that's some work for you. I want you to list down every one of those numbers into the colour group and then try to name them and talk about what property they have in common and what important little one is missing. Okay, let's go on now and have a look at the answers. Okay, we've got some answers here. How many colours were there? There were 6 colours. I've listed them here. Maroon, that's what Americans would say. We say maroon, and that's like a dark red. That was a dark red. Then we have a red. We've got a dark green, a light green, a blue and a brown. Did you get those? And listing them all down, I haven't listed them. Okay, I cheated a little bit there, but I have written down what you might have found as the properties. The red, dark red, or the maroon ones are all whole numbers. Okay, but they don't have factors except themselves and one. They're called the set of prime numbers. Hey, what's he talking about here? What do factors mean? Well, things that will divide in numbers, natural numbers will divide into the given number. A natural number of times goes exact, if you like. We're going to talk about that. So don't panic. If you've forgotten a lot of this stuff or never seen it, we're going to do it all now. Just listing down our tools here. The red ones, what do you notice? They've all got this sign here. And they're all the square root of a number. What's a symbol for any number, an unknown number? It's a letter, it's a pronumeral, and we use X. That's a little bit of an aside here. We're not actually interested about X in these presentations. We're interested in this square root sign. It's called a radical or square root sign. A radical or square root sign. And numbers that are written that way are called surds. You might not have seen that, so that's something you can look forward to learning. And then dark green numbers are all the whole numbers and are called the set of natural numbers. Okay, so here they may have factors. Okay, I haven't sorted them out where they may have factors. Okay, apart from themselves and 1. What about the light green ones? They're also whole numbers, but they've got a negative or minus sign in front. One sign like that. Sometimes it means minus and sometimes it means a negative. Do you know when? We're going to learn that. That's going to be great. And the light green ones have a negative, and if you put them with the set of dark green and 0, they call the set of integers, or the complete set of whole numbers. Hey, is this starting to spin you out? Don't worry. We want to look at all this. I just want you to see the difference between these numbers at the moment. And the blue numbers, these all have a number written at the top. What's going on there, mate? What's a number sitting up there doing? Okay, and this is called the index or exponent form. This is called an index or an exponent or a power. Sometimes called a power. And what that means, we want to look at. And then the brown, these all have one integer divided by another. Now you've seen them before, something like 2/3. And these are called fractions or ratio now numbers, ratios, because it's a ratio or one over the other of integers. You've got one integer over another. And did you notice within that set, sometimes the top one is bigger than the bottom? Do you know the name for those different types of fractions? Well, doesn't matter at the moment. We're going to learn that. And what's the missing number? I hope you saw that. It's only one little dude. It's 0. 0 is a special number, and it is a member of the set of integers. In between the negatives and the positive, has a very important position there on the number line, and we want to look at that also later on. So how are you going there? I want you to at least understand how we group the numbers and all the definitions and stuff and the maths we're going to pick out now. So come down now and let's have a look at getting up close and personal with our tools here. And the first set of numbers, I've taken these screen clippings from Hayes and Harris publications, are the natural numbers. The natural, why are they the natural numbers? 1, 2, 3. Well, they're the counting numbers. They're also the numbers that by nature, back in the caveman days, they might have used some sort of symbol like this to indicate a whole number of things, like I've gone out and got three rabbits to eat or something like that, and they're the counting numbers. So it seems to be a natural way of trying in mathematics to describe whole numbers and numbers of things. Okay, numbers of fingers on a hand or something like that. So we needed some counting numbers. So the natural numbers are like them. But can you see here, within this little set of natural numbers, there are a couple of different types. Okay, you might pause the presentation and say, can I see already that there are 2 different types of natural numbers within this set? Right, have a look. I'll show you the answers now. The ones I'm putting an arrow next to are ones which cannot be divided by another number, a whole number of times, or a natural number of times, except themselves and 1, because 1 is 1 by 1. 2 is 2 by 1, 3 is 3 by 1, but 4 can be written as 4 by 1 and also 2 by 2. 6 can be written as 6 by 1 and 3 by 2. So every number has 1 as its factor, but some have more. They can be written as a product of 2 other numbers, other natural numbers. So these are actually called composite numbers, and the others are called prime numbers. So we'll have a look at breaking them down later on, but just interesting observations. All numbers are not the same. They're structured differently and they have different properties. Okay, come on down now and let's look at that word of factors that I've introduced. The factors of a natural number are all the natural numbers which divide exactly into it, leaving no remainder. What's a remainder? Hey, what could you say? 7 divided by 3. 3's into 7 goes 2 times. 2, 3, 6, and a remainder of 1. which if you remember perhaps your earlier mathematics, you've only got 1/3 of what you need to go to the next integer number of 3's into 7. So you've got 2 1/3 of the next 3 to make up a 7. Okay, well, that's the idea of factors. 9 over 3 has 3 as a factor because it goes a whole number of times. 3 3's are 9 with no remainder. Do you get it? Okay, and then the highest common factor, common sense in maths, HCF, there it is. Of a set, you might have more than one number, and it's the largest factor, which is common to all of them. You might say, Huddy, this is getting a bit boring. You're just talking about definitions and rules. Can you show me something useful? We're going to, just in a minute. We just got to get our language and our definitions right to start with, and then we can see how to use them. So come on down, let's take an example here from Hayes and Harris. Find the highest common factor of 24 and 40. Well, hang on. How do you get the factors of a number? Well, here we go. Let's go over here. We're trying to break it down. Factors are two numbers multiplied together to give the number. So they're actually breaking it down into pieces. Let's divide 24 by the first natural number. It's 1. That's 24. So we've got those two factors. Let's divide it by 2. And it goes 12. We've got those two factors. Let's divide it by the next natural number. 3. 8 3 is 24. So we've got those two factors. Let's divide it by the next natural number. Can you get the idea? 6 4s are 24. So it's 6 by 4. We divide it by the next natural number. It goes 4 5s are 20 and a remainder of 4. So that 5 is not a factor. Let's divide it by 6. 4 6 is 24. So it's 4 by 6. And we're going to start to repeat ourselves now. 8 divided by 8. It's 3, so it's 8 by 3. So once you get to here, which is a repeat of that one in a different order, you can stop. We're going to repeat them. So there's our set of factors. Okay, so we put them all down. 1, 2, 3, and 4 all go into it. There it is there. And then we can say it goes 6 times, 8 times, 12 times, 24 times. There we are. That's a system by which we can write down the factors. Factors of 40, I'd like you to try and do the same thing. 40 divided by 1 is 40, divided by 2 is 20, and we're going to start to list down all the natural numbers that divide exactly into it, and their partners. Their partners called the factors. Okay, so what we're doing with factorisation is a breakdown approach, breaking the number down into a product. And the process is called factorisation, breaking down into factors which multiply together give the number. And what's the highest one that is a factor of both? There it is in red. 8 is the biggest number that will divide exactly or be a factor of 24 and also 40. So we state our answer. Very important in maths to put out your working as a solution and state your answer. Not so much for these simple problems, but later on, people want to know a proof, if you like, a reason for your answer. All right, can you do it? Come down, and I want you to have a go. So I've screen clipped Hayes and Harris publications here and split it into just the factorisation. So I want you to do question 1 and 3 and leave out 2 and 4 for the moment because they are something different. Okay, I want you to pause the presentation now, try to use what I've said before there and see if you can find the answers, the factors and the HCF of those. Okay, all right, so pause it. I'll show you the answers now. Coming down, there are answers. So I want you to check your answers off, make sure you understand what's going on. Okay, and we want to go on with the next little idea. Okay, next idea is about multiples of numbers. Now multiples are multiplying, as the word suggests, multiplying it by another natural number. So if I took 3, what's the first natural number? 1 by 3 gives 3. 2 by 3 gives 6. So it's the opposite sort of thing, isn't it? We're actually building up, not breaking down. Build up into bigger and bigger numbers using other natural numbers rather than dividing by them and breaking them down. Okay, so this time we're going to look at the lowest common multiple, or LCM, usually in capitals, of a set of natural numbers, or two or more numbers. And that is, the lowest one is the smallest one, which is common to all of them. You might say, Huddy, this is getting boring, you promised it would be useful. Well, this is the last couple of exercises, and I'm going to show you how to use it. So come on down here and let's have a look at an example from Hayes and Harris, and find the LCM, lowest common multiple, of 6 and 8. Let's look at the multiples of 6. 1 6 is 6, 2 6 is 12, 3 6 are 18, 4 6 is 24, 5 6 is 30, 6 6 is 36, 7, got the idea now. Multiples of 8. 1 8 is 8, 2 8s are 16, 3 8s are 24, 4 8s are 32, 5 8s are 40, 6 8. Well, what's the lowest one? Here we are. We've gone far enough, I think. And you could get more crossing over or common multiples up here. But we want the lowest one. It's 24 and then it's 48. The lowest one is 24. And I'm going to ask you to do some problems in a minute, just on the basics. Then I want you to have a look at why this is useful. Okay, so come down, and from Hayes and Harris there's question 2 and 4, which I've plucked those out because they're multiples. Multiples are build-up problems, getting bigger and bigger numbers. Factorising is breaking a number down into a product of factors. Pause the presentation and have a go, and do every part for practice there. Okay, let's have a look at the answers. There are our answers. You need to check them. If any are wrong, go back and see what is wrong using the process I've given you there. Now, I guess you're sick of all the practice. Let's see if we can use it now. Mathematics is very useful. So here are some problems. The first 5 there, 5, 6, 7, 8, and 9. And what I want you to do in looking at these problems, here they are over here. What I want you to do in the first two is to say, is it a breaking down problem? Are we looking at common factors? Or is it a build-up problem? With time, do they, or with successive multiplications, do they build up into common multiples? And what's the lowest one, the quickest they do that? So the analysis of these questions in relating to the theory are the Huddy words here. Is it a breakdown? So you're looking at factorising, factorising the numbers, or is it a build-up? A build-up, in which case you're looking at multiples. Do you get the idea? I want you to get up close and personal, and that's where these names are important in getting up close and personal with these processes and these numbers that you're going to be working with. Right, I think this one is just straight. This pair is just straight exercise. Only this time you've got 3 numbers to work with, so you have to break them all down or build them all up. Okay, check it out. Let's come down to 9 and 10. And again, it's a practical problem. You look at practical problems, both of them. Are you looking at a breakdown or a build-up? Pause it and have a go. And I'm going to show you the answers to all those now. Okay, so you need to check all those out and see what you think. All right, well, we're just starting out with the tools of our subject. I'm going to go on with this in a further presentation, more with those numbers that we saw on that first page in Pythagoras' box of numbers, if you like, and try and get up close and personal with those as well. I hope you're going to enjoy this. Cheers for now. I'll catch you a bit later on.